So we have different hydrogeological flow models. We have different hydrogen flow models, which are again something you can remember as the models which are available for doing the soil, land, and geology assessment. And these were not discussed much in detail, so you don't need to know the functionings and workings of these models, just to know. Hello? Okay. Um, and then moving on to lecture 35, we look up at EIA methods, climate and climate change, part one. Part two will be in next week's content. And we looked up at the introduction, which is Intergovernmental Panel on Climate Change report of 2021, which is again a very significant report in terms of bringing the climate change to the general public, especially after the COP27 in Glasgow. And it highlighted that the extreme events are happening at much faster compared to the last decade. It has been happening at a much faster rate in terms of waves, in terms of world waves, and all of these extreme events happening, flooding, and things like that. And the frequency of these impacts is also increasing. So it brought climate change to the discussion panel, uh, to the common man. So we look up at climate change policy. So there are two types of climate change policy. The first talks about climate change mitigation, which is the reduction of the causes of climate change, that is lowering the carbon emissions. And the second talks about climate change adaptation, which is to ensure that developments which are happening now will be resilient to unavoidable climate change. And then there are current challenges in assessment, which is in terms of cumulative impacts, because climate change is leading to a whole range of impacts, and all of them are happening at the same, almost at the same time period. So, accumulating the impact from climate change is one of the challenges in assessing the climate change. So your project as well, and then the risk and uncertainty around it, the time horizons and lifetimes, and the interactions, because all of this is a very uh, in terms of assessment, all of these things are a very newer look at environmental impact, and how to assess them is a challenge right now. All of these 4 points which are. And then we also looked up at definitions and concepts. So we looked up at adaptation, which is the process of adjustment to actual or expected climate and its effects. And in human systems and in human beings, adaptation seeks to moderate or avoid harm or exploit beneficial uh, opportunities. And in some natural systems, human intervention may facilitate adjustment to expected climate and its effects. Then we also looked up at adaptive capacity, which is the ability of systems, institutions, humans, and other organisms to adjust to potential damage and to take advantage of opportunities or to respond to consequences. So, adaptation is basically when you try to uh, adapt or take in whatever the situations and conditions are, and you try to uh, live with that. And adaptive capacity is the limit to which you can take those sort of changes. And then climate, again, there's a difference between climate and weather. So climate is, in a narrow sense, is usually defined as the average weather, or more rigorously, it is defined as the statistical description of the mean and variability of relevant quantities over the period of time, ranging from months to thousands of years or billions of years. And the classical period for averaging these variables is 30 years, as defined by the World Meteorological Organization. So when you look up at climate data in terms of climate files, you see a TMY, which is a typical meteorological year, and it considers data from 30 years beyond, um 30 years previous to the year for which you are looking that data for. And the relevant quantities are most often surface variables such as temperature, precipitation, and wind. And weather is something like everyday climatic conditions, whether it's sunny, rainy, and things like that, whereas climate is over a longer duration of time. And climate change is a change in the state of climate that can be identified, that is by statistical tests, and by changes in the mean and or the variability of its properties, and that persists for an extended period, typically decades or longer. And climate change may be due to natural internal processes or external forcing, such as modulations of the solar cycles, volcanic eruptions, and the persistent anthropogenic changes. So, anthropogenic changes are like human caused changes in the composition of the atmosphere or in the land use. Then climate projection is the simulated response of the climate system to a scenario of future emission or concentration of greenhouse gases and aerosols, generally derived using climate models. So climate projection is when you try to predict the climate for future years. And so we have something like a climate projection for. So at the moment, the climate projections are based on the mean temperature of the mean globe temperature, and they are mean globe temperature, and they are basically climate change projections. So they are so the targets which are set to mitigate, which we are trying to mitigate in the climate. Uh, in climate change assessments is basically to keep the globe temperature below 1.5 degrees centigrade. That is, the global temperature in the future years should not go beyond the globe temperature now plus 1.5 degrees centigrade. And there are other projections as well like this, where the temperature will go up to 2 degrees, will have an increase and a decrease of 2 degrees, and things like that. And then greenhouse gases or GHGs are gaseous constituents of atmosphere, both natural and anthropogenic, that absorb and emit radiation at specific wavelengths with the spectrum of infrared radiation emitted by the Earth's surface, atmosphere, and clouds. And greenhouse gases include things like ozone, methane, nitrous oxide, carbon dioxide, and things like that. You are aware of this. And then in terms of impacts, we look up at consequences and outcomes. So consequences of realized risks on human and natural and human systems. And risks result from the interaction between climate-related hazards, including extreme weather, climate events, exposure, and vulnerability. And impacts are generally referred to effects on lives, livelihoods, health, well-being, ecosystems, and species. Also, in terms of ecological, social, cultural assets and services, including the ecosystem services which we get, and the other biological systems get, and the infrastructure. And the impacts may be referred to as consequences or outcomes and can be adverse or beneficial again. And mitigation of climate change is a human intervention to reduce the sources or enhance the sinks of greenhouse gases. And then resilience is the capacity of social, economic, and environmental systems to cope with a hazardous event or trend or disturbance, responding or reorganizing in ways that maintain their essential function, identity, and structure, while also maintaining the capacity for adaptation, learning, and transformation. So these are all terms related to climate and climate change. And a sink or the carbon sink is any process or activity or mechanism which removes a greenhouse gas or an aerosol or a precursor of a greenhouse gas or aerosol from the atmosphere. So something which absorbs the carbon emissions causing climate change is known as a carbon sink. And so you would often have heard that the Amazon forest is a carbon sink. So that is the uh, definition justification for it. And then vulnerability is also something which we discuss when we talk about climate change, because vulnerable groups are more threatened by climate change. And vulnerability includes the propensity or predisposition to be adversely affected by any event. And vulnerability encompasses a variety of concepts and elements, including sensitivity or susceptibility to climate change. ability to harm, or capacity to cope and adapt. And then in this module, we also looked up at key legislations, guidance, and standards around climate change. So we looked up at California Environmental Quality Act. We looked up at climate change vulnerability assessment framework for infrastructure, the guidance for integrating climate change and biodiversity into environmental impact assessment, the IFC's performance standard on environmental and social sustainability, and the climate change resilience and adaptation. So all of these are legislations and guidances to clim- adopting climate change and assessing climate change impacts in the EIA project. But of course, there are major challenges to integrating it. And then we can now move on to question and answers. So these are questions from the previous round of the NPTEL course, and then we will also discuss the questions from week 7 assignment, because the deadline for the same has passed. So if you want to answer the questions, you can post them in the chat box. I will moderate the chat box as well for the answers. Okay. So the first question is, match the following terms of Group A with their description of Group B. So this is from lecture 31, which talks about EIA impacts from on air assessment. So the Group A talks about critical level of air pollutants and critical load of air pollutants, and Group B talks about the definitions of the two. So again, definitions are important examination point of view. So remember the definitions, or at least remember the keywords in the definitions to have a understanding of the terms. So what is the definition of air pollutants and critical load of air pollutants? Okay, so the correct answer is air pollutants critical level is the concentration of pollutants in the atmosphere above which adverse effects happen or felt by the visitors like human beings, plants, ecosystems, and things. And air pollutants critical load is the quantitative estimate of exposure to one or more of these pollutants and their harmful effects on the receptors. So P matches with 1 and Q matches with 2. So A was the correct answer. Again, definitions are important. Make a note of it. Please remember them for examinations. Okay, moving on to question 2. Select the following atmospheric pollutants considered for National Ambient Air Quality Standards, NAAQS, set by the CPCB, the Central Pollution Control Board, which are also considered for EIA. So the CPCB has identified 12 air pollutants, and it gives the permissible level of concentrations in residential, industrial, in other settings, as well as for eco-sensitive zones for all of these 12 air pollutants in the air. Okay, this was also something which was covered in lecture 1, if I remember correctly, or in the week 1 module, where we talked about air pollutants. Okay, so the correct answer is D, all of the above. So in the 12 air pollutants, we have sulfur dioxide, SO2. So sulfur dioxide also is a major constituent of acid rain. Then we also have oxides of nitrogen and particulate matter, which is, of course, particulate matter 10 and particulate matter 2.5, which leads to a lot of health effects as well. So all of the above are atmospheric pollutants, which are considered by the uh, National Ambient Air Quality Standards, NAAQS, which was set up by CPCB. So D was the correct answer. Okay, moving on to question 3. For scoping process in EIA, a particular atmospheric pollutant will depend upon A, nature and scale of the development, B, sensitivity of the receiving environment, C, baseline conditions of the area under study, and D, all of the above. Okay, so this question again is from lecture 31, which was on EIA process for air assessment part 1. And it looks up at the scoping process. It's asking if what factors need to be considered while we're looking up at scoping for any particular atmospheric pollutant. The correct answer is D. That is, all of these factors need to be considered when we are doing scoping for AIA. So we need to look up at the nature and scale of the development. That is the nature and scale of our project and uh, what sort of air pollutants it is going to discharge. Then it also in terms of the construction phase and then the different activities of the development, the sensitivity of the receiving environment, that is the location of the project site, whether it's in a residential area or if it's in an industrial setup, what is the sensitivity of the uh, surrounding environment. And it also needs to look up at baseline conditions of the area under study. So all of these are factors which needs to be considered when we are doing scoping for the particular atmospheric pollutant in the environmental impact assessment. Okay. So D was the correct answer. Moving on, question 4. On what basis the selection of the equipment to measure air pollution is done? A. Intended use of the data. B. Budget allocated to purchase or hire the equipment. C. Expertise of personnel available to set up and maintain the equipment. And D. All of the above. Again, on air pollution assessment, what factors or things do we need to consider when we select the equipment for measuring the air pollution? Again, D was the correct answer. That is, the intended use of the data is what is first thing essential for determining what sort of data do we need, what at what sort of interval do we need it. So the intended use of data is the first thing that you need to consider when we select the equipment. Do we need to go for a higher frequency taking setting, or do we are okay with a lesser frequency setting of the data? Then the budget allocated to purchase or hire the equipment. If the budget is agreeable, then you can go for the expensive equipment. But not, if it's limited, then you need to go for the lesser uh, lesser precision equipment. But then again, you need to have your options sorted out again based on the budget point of view. And then third is again the personnel for setting up the equipment and to taking for maintaining the equipment at the site. The personnel is again important. So all of the three factors were are considered when we select the equipment for measuring the air pollution. So D was the correct answer. Okay, moving on to question 5. Identify the model shown in the image used for impact prediction and evaluation of air. So the first option is wind tunnel and physical scale model. B, the second option is passive diffusion tube and physical scale model. The third option is pneumatic tube and physical scale model. And D, all of the above. Okay, we discussed this in the lecture 32, I think, which was the part 2 of air models. So this is a wind tunnel and physical scale model. So this is the physical scale model, which is made to scale at a limited scale. And then this is the wind tunnel. On the other side, there's again a fan. This is the wind. This is for blowing the wind at the speed specified. And these are again for wind from different directions. So you basically have wind being simulated through the model. This is a wind tunnel and a physical scale model. So A was the correct answer. Moving on to question 6, state true or false. With numerical dispersion models, we can calculate how specified emission rates are transformed by the atmospheric processes into pollution concentrations at different distances from the source or sources of the pollution. Is the statement true or false? So this is again the use of true or false. The use of definitions or the purpose of the dispersion model. Okay, we have an answer. True, yes, the statement is true. Numerical dispersion models are used for calculating the specified emission rates being transformed by the atmospheric processes into pollution concentrations at different distances from different sources. So the statement was true and the answer was correct. Okay, moving on to question 7, which is match the following terms of group A with their description in group B. So in group A, we have examples for the different type of sources for air pollution, which is line point, single point source, line source, area source, large number of point sources. And group B are basically examples of these sources. Okay, so you need to think in terms of what the sources mean. So something like a line source means a source which runs on a linear line. So I mean that's a hint. So things like uh, railways, airport runways, and things like that are line sources, whereas single point sources are industrial stack or vent. Yes, B was the correct answer. Yes. Large number of point sources are like ponds, settling tanks, open cast mines, or quarries which have multiple stacks or emission chimneys. So there are large number of point sources. Area sources are like large construction sites where there are large number of um, emission sources. Then you have car parks with a lot of cars, and there when the motorway service stations, industrial processes with numerous vents, urban areas, county regions, storage lagoons. So these are all area sources. Line sources are again like open roads, street canyons, railways. So you can associate the literal meaning of the word to the settings and see which matches. So the correct option was P matches with 2, Q matches with 1, and R matches with 4, and S matches with 3. So B was the correct answer as stated by you all as well. Okay, moving on to question 8, the equation of the return period or recurrence interval when which tells us the chances of the same flow of rain increasing in a year is written as so the return period is defined in terms of P, which is the probability of exceedance. Okay, so again, formulas are important. So the return period is basically the inverse of probability of exceedance. That is, if you want a 2-year return period, the probability is 50%. Okay, so again, formulas and their variables are important. Okay. Moving on to question 9, again a formula-based question. So the correct formula for Thornweight and method of 1955 to estimate water budget is, so it's expressed in terms of precipitation P, surface runoff R, groundwater flow G, evapotranspiration ET, and change in storage in a specified time period as delta S. Okay, so the correct answer is C. That is, in order to estimate water budget, we consider the precipitation or the rainfall minus the surface runoff to the drains, that is the water which did not go into the groundwater recharge, minus the groundwater flow, which is G, minus the evapotranspiration, which is the water being lost by rivers and trees and leaves through transpiration or evaporation, and all of these together equal to the change in storage in a specified time period. So this is the equation given by Thornwaiter and method in their method to estimate the water budget. So the correct option was C. Okay, moving on to question 10. Match the following terms of group A with their description in group B. So these are again definitions and their terms. So group A are terms related to water assessment, and group B water and soil assessment, and group B are the definitions for these terms. So we talked about evapotranspiration in the last question as well. Okay, so evapotranspiration is the combined loss of water vapor from the surface of plants, transpiration, and the evaporation of moisture from soil and other surfaces, such as lakes, rivers, and oceans. So P matches with 3. The bed load is the riverbed particulates, which range in size, such as so that they can be silt, they can be coarse sands, gravel, or even boulders, like large boulders or rocks. So bed load is the riverbed with different sizes of uh, particles, which range from silt, very fine silt, to solid large boulders, which you can fold as well. So Q matches with 1. And fluvial geomorphology is the process of water and sediment movement in rivers and their floodplains, together with the forms produced by those processes. So R matches with 4. And then S is geomorphological threshold, which is a condition allowing landform stability, a dynamic equilibrium through many factors playing their coordinated role. So S matches with 2. So the correct option was D, which is P3, Q1, R4, and S2. Okay, so again, definitions and terms are important. Please make a note of these, or at least associate keywords with each of these with for each of your terms, so as to have a better understanding of them. Okay, moving on to question 11. Name the type of soil order as shown in the image, which typically occur more in cold and wet higher ground, on wide and relatively flat interfluxes, and in low-lying receiving sites. We have different soil orders as the options. This is again from the module on soil, land, and geomorphology. Okay. So the correct answer is podisol, whereas oxysol has different layers from A, B, B1, and things like that. But this is the order for spodosol. Okay, moving on to question 12. We have matched the following type of map with their significance. So group A talks about maps, and group B talks about their significance or what these maps show. So again, from the module from for land, soil, and geomorphology, AIA assessment. The map and what it shows or its significance together. We have two options which use both the two options, which is one and two, and then we have two options which match with the same option. Okay, so the correct answer is that solid maps show pre-quaternary rocks, whereas drift map shows superficial quaternary deposits, which were more recently laid down by the movement of wind, water, ice, and other natural elements. So solid maps P matches with 2 and Q matches with 1. So B was the correct option. Okay, moving on to question 13, state true or false. The FAO guidelines for land evaluation provide a set of principles and a methodological framework for assessing impacts and compliance with the UN programs for sustainable development. Is this statement true or false? So this again talks about land evaluation. Again, guidances and their compliance with with programs on sustainable development goals or significant programs like UN programs are important. Legislations and policies and things are also important, especially if they are from an Indian perspective as well. Okay, so the statement is true, and we looked at it in the highlights as well. Okay, so moving on to question 14. Okay, match the following terms with their descriptions in Group B. So we discussed this in the climate change assessment module. We looked up at climate change, vulnerability, climate projection, adaptation. Okay, so the correct answer is so climate change is a change in the state of climate that can be identified by changes in the mean or in the variability of its properties, and that persists for an extended period of time, typically decades or even longer. And then vulnerability is the propensity or predisposition to be adversely affected. So vulnerable groups are more affected. True. And then climate projection is the simulated response of the climate system to a scenario of future emissions or concentration of greenhouse gases and aerosols, generally derived using climate models. So R matches with 2, and adaptation is a process of adjustment to actual or expected climate and its effects. So S matches with 1. So the correct option was B, that is P matches with 3, Q matches with 4, R matches with 2, and S matches with 1. Again, definitions and terms important. Okay, moving on to question 15. Again, terms and definitions. Match the following terms in Group A with their descriptions in Group B, again from the climate change assessment module. So we have adaptive capacity, carbon sinks, greenhouse gases, and mitigation of climate change. So I believe this is fairly simple because you would already know greenhouse gases, you would know carbon sinks, peak capacity, and the mitigation of climate change. Okay. So the correct answer is A, yes. Don't I think there is someone in the lobby. Yes. So the correct answer is A, yes. As you correctly stated, so adaptive capacity is ability of system, institutions, humans, and other organisms to adjust to potential damage or to take advantage of opportunities and to respond to consequences. Carbon sinks are any process, activities, or mechanism that remove greenhouse gases, aerosols, or the precursors of greenhouse gases or aerosols from the atmosphere. Greenhouse gases are gaseous constituents of atmosphere, natural or human generation generating that absorb or emit radiation at specific wavelengths within the spectrum of infrared radiation emitted by Earth's surface, atmospheres, and clouds. And mitigation of climate change is any human intervention to reduce sources or enhance the sinks of greenhouse gases. So P matches with 2, Q matches with 3, R matches with 4, and S matches with 1. So A was the correct option. Okay, I believe there is a question from somebody has their hand raised. If you have a question, you can ask now. Okay. Not, then we can continue. You can ask your question later. Okay, so now we will discuss week 7 assignment because the deadline for the same has passed, so we can discuss the answers to week 7 assignment as well. So we have the first question, which is what are the effects of air pollutants? One, it causes inflation, sensitive, sensitize, and scar the airways. Two, can affect lungs in extreme conditions because of long duration of exposure. Three, pollution can reside permanently in the body. And four, impact can vary from irritation, serious illness, or even early death in some cases. So, which of these statements are true? Okay, we have an answer. Okay, which is the correct answer. All of these statements are true. So, all of these are effects of air pollutants, and I'm fairly aware that I think all of you understand all of these effects. So, yes, the answer was correct. So, D is the correct answer. Okay, moving on to question 2. State true or false. Air pollutants critical level is defined as concentration of pollutants in the atmosphere above which direct adverse effects on receptors such as human beings, plants, ecosystem, or material may occur according to present knowledge. So, is this statement true or false? This is again from the definition of air pollutants critical levels. Okay, we have answers in the chat box that say that the statement is true, which is the correct answer. Okay, so again some definitions, and yeah, these are the critical levels. Okay, moving on to question 3. State true or false. International Finance Corporation, or the IFC, provides Performance Standards 1. It is an international benchmark for environmental and social risk management. So it talks about the IFC's Performance Standard 1. And it says that Performance Standard 1 is an international benchmark for environmental and social risk management. So is the statement true or false? So again, the IFC has 8 standards for different, which look up at different things like biodiversity, labor, climate change, and things like that. Okay, so we have answers in the chat box which say that the statement is true. Yes, the statement is true. The performance standard 1 from the International Finance Corporation is an international benchmark for environmental and social risk, and it talks about risk management. So this is correct. So the answers were correct in the chat box as well. Okay, so moving on to question 4. Again, match the following. So match the following types of impact prediction and evaluation models given below. So we have the different uh, evaluation models for air pollutants, and we have their description or impact prediction methodology. Okay, so we have answer coming in the chat box. Okay. Okay, all the answers are C, so I believe C is correct. Yes. So numerical dispersion models are used to calculate how specified emission rates are transformed by the atmospheric process into pollution concentration at different locations for different sources of pollution or for a single source of pollution. Whereas simple or screening models are based on simple assumptions taken about the behavior of pollutants in the atmosphere, and they can be used with the limited meteorological input data, such as minimum and maximum ambient air temperatures and minimum wind speed, which with worst pollution concentrations can be estimated. The Gaussian model is considers the pollution emission spreads outwards from the source in an expanding plume aligned to the wind direction. So we also looked this up in the diagram for the Gaussian model. So yes, the answers were correct. So C is the correct answer. P matches with 2, Q matches with 3, and R matches with 1. So all of you were correct. Okay, moving on to question 5. Match the following odor effect assessment models. So we have the three different types of odor effect assessment models and their descriptions and what sort of what they undertake. So we have the risk-based assessment, the semi-quantitative assessment, and the dispersion modeling. Okay, so again, we have a lot of answers coming in. Okay, so most of you have answered C. Okay, I think everybody has answered C. Okay, C is the correct answer. So risk-based assessments look at the pathway and the receptors, and then they draw conclusions based on the pathway and receptor link. And then semi-quantitative assessment look up tables to predict the odor concentration, whereas the dispersion modeling predicts and compares with the benchmark value, what are the expected values and our case values, and then look up at those results. So P matches with 2, Q matches with 3, and R matches with 1. So all of you were correct. C is the correct answer. So moving on to question 6, state true or false. ADMS, EPA's CAL3 QHC, Caline 4 modeling are used for different countries for road traffic air pollution modeling. Is this statement true or false? Again, we looked up at these standards or modeling methods for different by different countries for the specific type of purpose. Okay, so we have answers in the chat box, which say that the statement is true. Indeed, the statement is true. So the ADMS load model is from UK. The EPA Cal 3 QHC is from the US or United States, whereas the Caline 4 model and yeah, there's only Caline 4 model, yes. Okay. So, yes, all of these models are are used for road traffic air pollution modeling, and the statement was true. Okay, moving on to question 7. Match the following surface and groundwater quality by assessing three classes of attributes. So you have the three classes of attributes, and you need to match them with their descriptions in group 2. Okay. Okay, so we have answers in the chat box. Okay, and we have okay. So the correct answer is C. So physical attributes include things like natural water vary in the amount of particulate material present in them. Rivers typically carry large quantities of particulate. So these are the physical attributes relating to surface and groundwater quality. Then the biological attribute relating to surface and groundwater quality is the presence of microbiological organisms and waterborne pathogens. And many of these can cause health issues for humans and animals. So these are biological attributes for the for the water quality. And then chemical attribute is the dissolved chemical solutes which originate from atmosphere, soil, or weathering of bedrock. And we need to understand that that water is never pure, and it has some sort of chemicals or biological content and things present in it at all times. So, so yeah, so the question was again in terms of surface and groundwater quality. So P matches with 2, Q matches with 3, and R matches with 1. So the correct answer was C, as most of you answered. Okay, so moving on to question 8, which is again a straight true or false. So water quantity assessment desktop study involves catchment boundary area, drainage pattern, and information on geomorphology, such as slopes geology, soil and land use, which can be determined from the base maps, geological and soil survey maps. Is this statement true or false? So again, desktop study is something which you can do sitting on your computer and looking up at data from different data sources and gathering that data from the respective organizations which collect them. And in terms of water quantity assessment, these are the things which are specified you can do from your desktop study. Okay, so we have answers in the chat box. Okay, so the answers say that the statement is true. Okay, so the correct answer is that the statement is true. The water quantity assessment desktop study involves catchment boundary area, drainage patterns, information on geomorphology, like slopes, geology, soil land use, which can be determined from the base maps, the geological soil survey maps, and other things. Okay, so you were right. Moving on to question 9, match the following. So we have in group 1 different definition, the different terms, and in group 2 we have the definitions. And we looked up at one of these things, which was the return period in a previous question. You need to match group 1 with group 2. Okay, so we have an answer in the chat box. Okay, so the correct answer is C, as you said. So base flow is the movement of water between the surface body and the groundwater. So P matches with 2. The return period is, it tells us the chance of the same flow of rain increasing in a year. So Q matches with 3. And the drainage basin approach is an approach in which the catchments are separated by a watershed boundary, which is a natural division line among the highest points of land and the precipitation, that is rain, snow, and so on. So R matches with 1. So C is the correct answer. Okay, so moving on to question 10, which is again match the following. So we have the different types of different purposes of maps and the scale for the different types of maps. So you need to match the different types of map based on their purpose and their scale. So a hint here is that for details, you need a large, like a very zoomed in map. So the scale is going to be much. Okay, we have answers in the chat box. Okay, so the correct answer is A, that is large areas or whole continent use a scale of 1 is to 20 million. That is, it's a very zoomed out map. Whereas regional maps zoom in a little bit on the region. So this they use a scale of 1 is to 1 million to 1 is to 250,000 scale. Whereas for details, you need to zoom in further. So details have a much lesser scale, which is 1 is to 10,000. So the correct answer is A, that is P1, Q2, and R3. Okay, moving on to question 11. Field survey of plant soils involved. One, required to collect baseline information on land and soil from field survey. Two, information such as landform, soil types, land quality, ground cover, land cover, and tenure. Three, GIS for spatial statistical analysis. And four, history maps. Okay, we have answers in the chat box. Okay, so the correct answer is A. That is, we for field survey in land soil, we usually require to collect the baseline information on land and soil. Then we collect information on landform, soil type, land quality, ground cover, land cover, and tenure, land ownership as well. And then we can use GIS to compile this information for spatial and statistical analysis. So only 1, 2, and 3 are correct. So A was the correct answer. Okay, and moving on to question 12, which is a state true or false. To estimate the soil pollution, two type of situations exist where EIA is used. So first is when the site is already contaminated and a cleanup operation is required. And two is soil pollution may be caused by the project itself. Is this statement true or false? Yes, so the statement is true. Only two type of situations around soil pollution require EIA. One is when the site is already contaminated and you need to do a cleanup operation. And two is when your project is causing soil pollution to the site. So in that case, also you need to do an EIA to give mitigation efforts uh, for soil for improving the quality of soil, basically. So the statement was true, as you stated. Moving on to question 13, state true or false. Greenhouse gases are gases constituents of the atmosphere that absorb and emit radiation at specific wavelengths within the spectrum of infrared radiation emitted by the Earth's surface, atmosphere, and clouds. Is the statement true or false? Okay, again, this is a fairly straightforward question based on definitions, of course, of greenhouse gases. Okay, so the correct answer is A, that is true. Moving on to question 14, which is match the following as per EIA context. So we have in column A, we have the broad purpose, which is mitigation, resilience, and climate change. And in group B, we have the specific purpose and activities relating to the broader purpose. So you need to match group A with group B. Okay, so the correct answer is A, that is mitigation. Climate change is a human intervention to reduce the sources or enhance the sinks of greenhouse gases. The definition of mitigation. Resilience is the capacity of social, economic, and environmental systems to cope with a hazardous event or trend or disturbances, responding or reorganizing ways that maintain the essential functions, identity, and structure, while also maintaining the capacity for adaptation, learning, and transformation. Whereas climate change is any process, activity, or mechanism that removes greenhouse gases or aerosols or a precursor of greenhouse gases or aerosols from the atmosphere. Okay. So A is the correct answer. That is P matches with 1, Q matches with 3, and R matches with 2. Okay. Okay, this was the end for question for the assignment from week 7. So if you have any questions, you can unmute yourself and ask now, or you can post your questions in the chat box. And again, the slides for these will be uploaded in the Google Drive folder, which is whose link is shared with you in the problem solving session tab in the NPTEL course on your left-hand side. And then also the link to the YouTube video will also be posted in that tab as well. So you can check this video again. Okay, you can post your queries in the discussion forum. We go through the discussion forum while we are preparing for the presentation for each of the week to address any queries which you guys have. Okay, if you do not have any queries. Okay.
Hi, hi,
Hi.
Rajesh here.
Hi.
Hi,
Hi.
good evening. I
Good
have a
evening.
small query because I am working the renewable energy. It's come under the white category. So, all as per IFC Schedule 1, Format 1, all parameter EIA requires, or for the white category, we have only few limited parameters which will checked.
I'm not sorry if I understood. You're talking about the IFC parameter one on
Standard
the
one. Yeah, yeah.
standard one, which is on
Yeah.
risk assessment, and you're talking
Yes.
about which parameter? Sorry.
I'm asking about the white category because we have a different from the industry category, na, where
Yes,
because renewable
yes,
energy have a white category. So
yes.
white category business, we require the detailed analysis all parameters. Other कुछ few parameters are excluded for analysis.
Okay, I am not sure about this. I will go through this and I will put it in the discussion forum with your name on it. I mean, I will answer this question in the discussion forum. I'm not sure at the moment.
Yeah, because we are not generated any byproduct, no any water pollution, no any air
Yes,
pollution. Only noise in one factor, which is we done on all these things, and we do frequently noise inspection all these things. So because when I go through the IFC parameters, I have a lot of detail.
yes, yes.
So just yeah,
Yes, so IFC parameters is are from an industrial, like from an industrial corporate point of view. So they have a lot
yes,
of details in it. So I will go through it and I will answer your question. So your
sure.
question is
Thank you.
basically around the renewable energy parameters, right?
Right, right, correct.
Yes, yes. Okay, yes. Right.
Thank you.
Okay, thank you. Okay. Okay. Does anybody have any more questions? Okay, if you do not have any questions at the moment, and if you have questions in the future, you can put them in the discussion forums. We will answer your questions in the next week, or if it's urgent, we can put them in the discussion forums as well. Okay, thank you for joining this problem solving session, and hope to see you next week for
Thank
week
you, team.
8. Thank you.
Thank you, team. Thank you. Bye.